Today was day 1 of Science Boot Camp. We did an experiment called Filling Without Spilling. This video will help those of you who were absent get caught up, and it can also serve as a review for those of you who were present today. The objectives of our lesson were that you will be able to conduct a fair experiment to collect data, that you will be able to apply these vocabulary words to a fair experiment and hear all of the vocabulary words that we're going to learn this week, that you will be able to analyze data in order to answer an experiment question. Those are going to be the same objectives every day this week. We're going to do an experiment Monday, Tuesday, Wednesday, and Thursday, all leading up to an assessment on Friday. The criteria for success, which is how you will know and I will know if you have done well, is that by the end of the day today, that you will be able to write a testable experiment question and label the independent and dependent variables. But by Friday, if you are given a procedure for an experiment you have never seen before, you will be able to apply the vocabulary words above to the experiment in writing. And we'll talk more about this every day, and you'll have an opportunity to do it Tuesday, Wednesday, and Thursday. Throughout this week, I will be asking you 2 questions. What are you doing, and why are you doing this? And I thought a little bit about that, and I want to share with you why we are doing Science Boot Camp and what the purpose is. There are so many discoveries in the world that have yet to be made. We know, for example, that many years ago, people thought that the Earth was the center of the solar system, and then we discovered, based on data, that the sun is the center of the solar system. If we want to participate in these kinds of discoveries that have yet to be made, we need to have a basic understanding of how scientists work and the vocabulary that they use for discovery. This week we are working on our scientist skills so that we can be ready to explore further. So if you get asked, why are we doing this? I hope that your answer will include some of these ideas. In summary, we're having Science Boot Camp Week so that we can learn the basics of how scientists work so that we can use those same skills that scientists use. A quick explanation of the experiment that we did today. We got 3 different types of water: plain water, salty water, and dishwater. And using a pipette, which is a small dropper, we dropped water onto pennies to see how many drops of each kind of water a penny can hold. We did 5 trials of the plain water, we did 5 trials of the salty water, and we did 5 trials of the dishwater. So we tried each kind of water 5 times on different pennies, and we counted how many drops of water the pennies could hold. The reason that we did 5 trials, or the reason we do repeated trials in any experiment, is to make our data more accurate. If we went with just 1 trial, we might not know if we had made an accidental mistake or if our data might mislead us when we make our conclusion. So the experiment question in any good experiment is going to be stated in this way: what is the effect of something on something else? So in our case, we were trying to find out what is the effect of different types of water, the fresh water, the salty water, the dishwater, on the drops of water a penny can hold. Any good experiment question will be stated in this way: what is the effect of something on something else? We have been hearing, and I'm reminding you again about the independent variable and dependent variable. Every good experiment changes one thing and measures one thing. When you think about independent variable, I want you to remember that it starts with an I, which should remind you of I change. The independent variable in an experiment is the thing that you change. And for this experiment, it was the different types of water that we used to drop on a penny. The dependent variable is the thing that you measure, and it might help you to think about D and dependent and what do I measure. In this case, we measured the amount of drops on a penny. Now, the constants is something we haven't really talked much about. A constant, that word constant means when something doesn't change. And in an experiment, there can be lots of different things that change, but a good, fair experiment changes just one thing. So we have to keep as many other variables constant or the same as we possibly can. That way we can be sure that our conclusion, or the data that we get and the conclusion that we draw based on it, is really affected by the one thing that we meant to change. So some things that we did not change that were constants were one, that we always use pennies. We didn't change and use nickels sometimes and dimes other times. We always use penny. Each cup had a half a cup of water. We used the same type of pipette. That's important because if you used a bigger dropper or pipette, you might get bigger drops of water. We used the same tray and paper towels each time. We had the same people on the teams doing the trials. We used the same kinds of cups for the water. We had the same directions to follow in this order and the steps of things. And we also put all of our pennies heads up. That's because the tails of pennies and the heads of pennies could hold different amounts of water. So we decided to be constant or consistent and use heads up. You need to, on your own paper now, fill in a prediction. You should pause the video and write, what do you think will happen in this experiment? And a prediction can just be a very informal statement. I think that, and tell me what you think is going to happen. A hypothesis is much like a prediction, but it's stated in a certain way. It's an if-then statement. So we're all going to have the same beginning of our hypothesis. If I drop different amounts of water onto a penny, and this is always the part that you're changing here, your independent variable will go here, then, and you need to finish the hypothesis with what you think is going to happen. Please make sure you have filled in the prediction and hypothesis before you move further in the video. So next we collected our data in teams, and since you can't do that now, here is the data from one particular team, and you can see that they had 5 students in their team, so they did 5 trials, each person doing each type of water. When you have 5 different trials, then scientists find the mean or the average of their data. That kind of gives you a middle number to help you represent your data easier. In order to find the mean of the numbers, you're going to add the numbers across and then divide by the number of trials that you had. So in this case, we're going to add each of these numbers for the plain water and then divide by 5 because we had 5 numbers. So it will look like 23 plus 15 plus 15 plus 4 plus 20. So we get a total of 77 for the water, the plain water, and then we divide by 5 because we have 5 trials going across, and we get 15 and 4/10. If you had gotten a number that had more digits behind the decimal, we would round to the 10th place, but this one's already rounded in the 10th place. Go ahead and do the same now for salty and dishwater. We also recorded some observations as we were doing our experiment. Remember that an observation is something that you see, hear, touch, taste, or smell. It's something that you find out based on your senses. It is not a guess about what might be happening. It's something that you can observe definitely that is happening. In class, we talked about an example of if you were in the classroom and you said, I smell smoke. Something smells smoky to me. That's an observation because you used your sense of smell to describe something. It would not be an observation to say, I think there's a fire in the next room. That's called an inference, when you make a guess based on what you know and your observations. So we made three different observations of things that we saw, heard, touched, and smelled. We obviously couldn't make any taste observations this time. You can skip this part on this lab sheet, but you will need to fill in observations on future lab sheets. We also explained at the bottom of our paper how you found the mean. Remember, we were adding and then dividing. Please be specific when you fill this part in. Next, we created our bar graph, and I want you to number your y-axis just like is seen here. Please note that the numbers are on the lines. Many students wanted to put their numbers between the lines like this, which is not correct. The digits go right on the line, and we counted by 5. Then you need a data table title. You're going to need a y-axis. What do these numbers mean here? You're going to need labels for each of your bars plus an x-axis label. And as we learned earlier this year, in a bar graph, the bars do not touch. So you're going to skip a row, skip a column, make a bar, skip a column, make a bar, skip a column, make a bar. And you're going to graph the data that the means that you found here when you did your adding and dividing. You're going to graph these 3 numbers in the last column. And I'm just doing this quickly, but here's what it'll look like when you, I'm not doing the accurate numbers. When you make your bars, you will have 3 separate bars that are each the same width, separated by an empty column in between. An inference is what we talked about before, is what you believe to be true based on 2 things: what you observe and your prior knowledge or experiences. So in this case, our inference might sound something like this. I think that the, and then pick one of the types of water, had the most or least because, and then tell what you know about that kind of water. So you need to look back at your data and find out what it tells you, the data that I gave you, and then make a statement about why you think you got those results. For example, if you found out that the salt water had the penny held the most drops of salt water, why do you think that is? What do you know about salt water or salt that could make it hold more? There's not a right or wrong answer at this point. I'm just asking you to take what the data and what you already know and make a guess, an educated guess. A conclusion always has 2 parts. The first part that it has is the answer to the experiment question. Remember, the experiment question is, what is the effect of different types of water on the amount of drops of water that a penny can hold? So answer that question. What did you find out based on your data? And then the second sentence is stated in a very specific way. You need to say either the data did support my hypothesis. That's the statement you would use if your hypothesis was correct. Or if your hypothesis was incorrect, you would say the data did not support my hypothesis. So please make sure that your conclusion has 2 parts. And finally, we learned 2 new words today: qualitative data and quantitative data. Qualitative data has the root word like quality, and qualitative data is data that we collect that's words only and doesn't have numbers. Quantitative data is when we collect data that is numbers, and that reminds you of the word quantity. So you need to decide, was this experiment based on qualitative data, that would be words, or quantitative data, numbers? And you need to tell which kind of data it was and explain how you know.